Hello and welcome. In this video, we'll discuss PV module end-of-life practices once reuse, repair, and remanufacturing options are no longer viable. Recycling of PV modules becomes a good option. Full high-value PV module recycling ideally consists of the following general process. First, removal of the metal frame and junction box. Second, eliminating glass and encapsulant from the laminated structure. Third, recovery of materials such as silicon and metals. During the second step, the structures are decomposed and the components are separated with metals recovered during the next steps. Due to the difference in the structures and components of PV modules, separate processes for crystalline silicon modules and thin film modules are often required. For crystalline silicon PV modules, glass, silicon cell, and wires and plastics are separated in the second step. For thin film PV modules, semiconductor material can be deposited directly on the glass structure. Thus, in the second step, we separate the separated parts are glass without semiconductors, glass with semiconductors, plastics, and wire. Finally, materials such as high-value silicon, silver, aluminum, copper, and toxic lead will be recovered and reused. Considering most thin-film solar cells are based on multi-component materials, they have to be separated as well. While such advanced PV recycling processes are being developed in universities, laboratories, and pilot lines around the world, the common practice is much different. It is typically driven by economic and regulatory considerations. It costs less than €1 to put a module in a landfill, while recycling of all materials in a PV module costs about €20. Unfortunately, the income one can generate from selling the recycled material is typically lower than the difference. Note that individual steps, such as the removal of the aluminum frame, can still be profitable, which leads to partial recycling. This means that there are little economic incentives for high-value PV recycling until recycling technology becomes cheaper or the material value increases. In such cases, regulations can help to ensure that recycling still happens. In the European Union, waste from electronic equipment or the e-waste regulation regulates end-of-life PV module. It states that more than 85% of all end-of-life PV modules have to be collected and then recycled with a recycling rate of more than 80%. When considering that 85% of a typical PV module is the glass plus the aluminum frame, this leads to quality recycling of aluminum frames and crushing of the glass together with the polymers and valuable semiconductor materials and other metals such as silver. This crushed glass with trace elements is then often used as filler material, which is not desirable from a sustainability perspective. One possible solution could be to design PV modules with recycling in mind. Here we see such an example of a small PV module prototype with liquid encapsulation replacing the traditional polymers, which makes the traditional PV modules more difficult to recycle. The advantage in recycling of these modules is that in the second step, which deals with the delamination of the polymer, in this case you can simply cut open the edge seal and have easy access to the glass and the semiconductor fractions already separated. To wrap up this video, we learned that about the 3 levels of PV recycling. 1. Removal of the external metal, 2. Delamination, 3. Recovery of the metals. We also learned that in practice, economic and regulatory considerations dictate PV recycling treatment and that PV modules can be designed for easier recycling. As we continue this course, we'll explore how other circularity strategies can be applied in other renewable energies. Thank you and have fun in the next session.